We are the final year student of Rajiv Gandhi College of Engineering and Research, Nagpur. The following video demonstrates our effort to increase the functionality and utility of the helmet so as to increase rider convenience and reduce accidents.
The title of our project is Intellectual Visor and Voice Instructive Helmet, whose prototype has been developed for Texas Instruments India Analog Design Contest 2013-14 under the guidance of Professor Praveen Vararkar.
The main objective of our project is implementing a low-cost audio informative system which enhances the functionality of helmet by providing voice instruction to rider, thus enabling him to make decisive decisions while driving. The system provides voice instruction to driver about his current speed, RPM of engine, fuel left in tank, and GPS navigation of mobile phone. Also, the system includes auto darkening of visor, which will avoid distraction to driver by high beam of opposite vehicles. Additionally, solar panels are also provided to charge the batteries. Further details and working of project prototype will be demonstrated in the remaining part of video.
In hardware section we have two different units, that is transmitter unit in vehicle and receiver unit in helmet.
The transmitter unit consists of a control unit, an encoder circuit and an RF transmitter. The control unit has a power supply section in which we have a voltage regulator UA7805 from Texas Instruments. It is used to get a constant supply of 5 volts. The control unit also has one Atmel 89S52 microcontroller which processes the input data from port 0, port 1 and port 3 and in according to the input produces an output on port 2. There are also 8 switches connected to port 1 in the input mode to input 8-bit digital value or speed manually. There are also 4 switches that are connected to port 3 in the input mode to provide 4-bit digital value of RPM to microcontroller. There are also 4 more switches connected to port 0 in the input mode to apply 4-bit digital data of petrol. There is also a crystal oscillator to provide clock of frequency 11.0592 MHz. Encoder circuit. Next we have the encoder circuit, which is used to convert parallel output data of the microcontroller to serial form. It consists of HT12E encoder IC which has 8 address pins for synchronization purpose, 4 input data pins and a transmission enable pin. There is one RF transmitter of frequency 434 MHz to transmit the serialized data. This is the receiver section embedded in the helmet. We have divided this into 3 sections. The first, the RF receiver, the second, the decoder circuit, and the third, the control unit. The RF receiver is again of 434 MHz to receive the transmitted data. The decoder circuit, which converts the received serial data into parallel form. We have used HT12D IC for this purpose. In the control unit, we have used 2 power levels. One is 5 volt for which we have used voltage regulated UA7805 and the second is 3.3 volt for which we have used an adjustable voltage regulator LP2950, both from Texas Instruments. There is a microcontroller MSP430G2553 from Texas Instruments which receives the 4-bit decoded data and from decoder circuit and accordingly produces an output of 8 bits. This is an EPR33A3C2 voice recording and playback IC which is capable of storing voice data for a duration of 680 seconds and it takes 8-bit output data of microcontroller as input. This is a microphone used for recording voice instructions in this IC. Speaker. This one is the speaker which connects to the output of APR IC to listen to voice instructions. There is also a nickel cadmium battery of voltage 7.2 volts and 300 milliamperes. We have integrated the receiver section with the helmet entity. It is also to be noted that whatever inputs are being made to the system are being made manually. One more thing is of notice that whenever the LED on the receiver section flashes, it indicates that a valid transmission has been received. One more thing is of notice that whenever the system is made active, a welcome note appears indicating that the system is now active.
Welcome, sir.
This indicates that the system is now active. The next parameter which will now be demonstrated is the petrol level. As soon as the ignition is turned on, the petrol level is informed to the rider. If the petrol level is below the threshold value, which in our case has been set to 2 liters, logic 0 is applied to D1 bit of the port 0. In case, however, if the petrol is above the threshold level, that is of 2 liters, logic 1 is applied to D1 bit of port 0. Now considering a situation in which the fuel is below 2 liters, the threshold value.
Petrol is below 2 liters.
Now considering that the fuel level is above the threshold value of 2 liters. The logic 1 is applied to D1 bit of port 0.
Petrol is above 2 liters.
This indicates that the petrol is above 2 liters. The next parameter which will now be demonstrated is the speed limit. The user is informed whenever he crosses certain speeds, like if the speed will be above 50 km per hour. In the above demonstration, a manual input is being provided to the transmitter section. Depending on the input received, the appropriate voice command will be given out.
Speed is above 40 km per hour.
On receiving the appropriate input, the appropriate output was generated, detailing that the speed of the vehicle was above 40 km per hour. Now, giving an input that the speed of the vehicle is above 80 km per hour. And please note that while informing the rider that the speed of the vehicle will be above 80 km per hour, it also gives a warning which has been preset that the speed of the vehicle is above the average speed limit.
Warning, your speed is above 80 km per hour.
Our system includes a solar panel which is used for the charging of the batteries.
Our next feature is auto darkening visor. For this, we are using active shutter LCD glasses. The property of LCD glasses is it turns dark as voltage is applied to it. For demonstration purpose and due to financial restraint, we are using 2 samples. The working of auto darkening visor is illustrated in the animation which follows.
As seen, when high beam of oncoming vehicle focuses on the rider gets distracted, which may prove dangerous. Whereas in second case, with the use of auto darkening visor, the intensity of high beam is reduced, which is much safer.
The intellectual visor and voice instructive helmet also comprises of Bluetooth headset which will be integrated within the helmet. This Bluetooth headset, when synchronized with the rider's mobile device, will help him to navigate through cities and any destination. With this, we have come to the end of our demonstration for the intellectual visor and voice instructive helmet. It is to be detailed that the helmet is integrated with the receiver section, the Bluetooth headset, the photosensitive visor and the solar panel.
We would like to extend our thanks to TI team, in particular to Dr. C.V. Ravi Kumar and Vaibhav Oswal sir for organizing such an encouraging competition and provide us with necessary help and guidance required at every step for the project. We would also like to thank our mentor Professor Praveen Vararkar, who has given time-to-time guidance and support in process of building this project. We are also thankful to our institute, which has helped us with all the type of technical facilities and cooperation, without which our project would not have turned to reality. Thank you.